as we usually do, and let us continue. And you don't need to write that down, that's just a scale. But what is the law of conservation of mass? There it is right there. There is the law of conservation of mass. The mass of reactants equals the mass of the products. And like I said, it is an experiment that, as far as I'm concerned, is more worth just demonstrating than it is spending 45 minutes to do this. Because in the end, we're going to have to balance some chemical equations, and that takes a little bit of time, and I'd like you to have the opportunity to work on the balancing so we can get my little balancing assignment done. So the law of conservation of mass means that during a chemical reaction, the mass is not affected. It is the same before and after, as long as the system is closed. All right? If I had an open system, some of that water might have sloshed out, and then I'd have a change in mass. But that's not a closed system. In a closed system, it'll be conserved. If the system's open to the air, you could spill some, and then it's not a closed system. Okay. So, law of conservation of mass, the mass of the reactants is equal to the mass of products. So why do we do this? We do this because it teaches us that when we have a chemical reaction, we have to balance it. We have to have the same number of atoms on both sides of the chemical reaction. And that's why yesterday we practiced counting atoms. Because in today's lesson, we're going to have an equation, and all of the atoms on the left have to equal the atoms on the right. So we've got to be able to count them. Okay? As you guys are writing that, I'm just going to do my attendance again. I see if I can sign in. I'm struggling to sign in here. Here we go. Okay. That is done. Chemical equations must be balanced. When we say balanced, it means that the atoms have to have the same number on the left as they have on the right. I actually introduced to you the term coefficient yesterday. Coefficient is a big number that we put at the front, in front of a chemical, and we can change that number in order to balance the reaction. Are you in need of anything particular? Yeah, by all means. There you go.
Thank you.
Yep. We also saw yesterday that we had the subscripts, the little numbers. The little numbers you cannot change. The little numbers are built into the chemical formula. They come from the crossover. So they're built in. You cannot adjust those. But we can adjust the big number as much as we want. Whether we have 1 water molecule or 2 water molecules or 3 water molecules, we can change that number however we need to in order to balance the equation. Again, I've got people looking at devices, so I don't know where we're at in terms of writing. I can be patient. We're good to go? So, I don't think you've ever done this before. You've probably never done balancing chemical equations in your life. So this is going to be a learning process. I plan on doing 5 or 6 examples, and then I'm going to give you an assignment where I want you to work through and try to balance them. The reason I'm giving it to you as an assignment is because you guys know if I give it to you as practice, some of you don't do it necessarily, but if I give it to you as an assignment, you're going to work through it, right? You're going to work through it to hand it in. I want to give you lots of time to hopefully get done it today. I do have it due technically, I believe, tomorrow at the end of the day, right? But it would be nice if we could get it done today. If you're going to do it on Google Classroom, that's fine, but some of you are realizing that you'd rather write it on a piece of paper and maybe just give me a piece of paper. That is always an acceptable thing to do. You can always do it that way. Okay, tips to help you balance. I'm going to let you write it down again, and then I want to talk about it, because this is the type of thing that takes some concentration, and we've got to do a little bit of logical thinking as well. Again, just like yesterday when we put a little chart paper up here to help us remember our times tables, again, if you can keep an eye on those times tables, you're going to make this job a little easier, because we've got to be able to count those atoms up just like we did yesterday. If you need a calculator to do quick times tables, get a calculator for this process. Don't try to necessarily do it out of your head if your weakness is times tables. I tell you right now, when I get down to, well, maybe not 5, 5's the easy one, but when I get to 6 times 7 or 6 times 8, I'm needing a calculator. I'm second guessing that, because I really didn't memorize these two either when I was a kid. I'm good with the lower ones, but when I get to 7 times 8 or, 8 times 8, 8 times 8, I need a calculator for that. So don't be afraid if you need a calculator, or at this point your phone is fine, but during a test I'd like you to have a calculator for it, all right? Okay, so first tip, this isn't a fraction. Very often in your chemical formulas, you're going to find that on one side there might be O2, like a 2, and on the other side there might be O3, like in a carbonate, CO3. So you're going to have this 2-3 scenario, which is really hard to balance, because how do you make a 2 become a 3? Well, when you get a 2-3 situation, what you can do is, an easy trick is, swap the number, multiply the one that's a 3 by 2 to make 6, and multiply the one that's a 2 by 3 to make 6. You see what I'm saying? Take the 2 and the 3, trade those numbers. So turn those 2's and 3's, you'll multiply them, make them become 6. Multiply them by the opposite number. And I'll show you examples of this. If it doesn't really make sense, you haven't seen anything yet, but very often you'll have a 2 and a 3, and if you swap those numbers and do a little trade there, you can easily make it become 6. If you do that first, your job's going to be a little easier. You also have situations where you've got 1 and 2. Let's say you've got 1 chlorine on the left, and then you've got a Cl2 on the right. Do the same thing. Multiply that thing by 2 so that the chlorines become the same. So swap those numbers around, okay? So keep an eye for those, and we'll do examples, and I'll show you how that works. Do H's kind of like second last, and O's do last. So H's and O's, or any element that's alone, do it last. If an element is all alone and you put a coefficient in front of it, when you do that, you're not messing up any other atoms. When you put coefficients in front of something that's a compound that has more than one atom, you're changing both of the atoms. So if you can do the thing that's by itself last, then you're only changing that last thing, and that'll save you some headaches, okay? So you want to do H's second last, O's last, or any other element that's alone. Recheck. When you're done, you want to take a check to see that everything is the same and you've got it balanced. So, one last thing. Never change the little numbers. The little numbers are determined by the formula of that substance. They cannot be changed. We cannot change the formula of substances just, by choice. They're determined by, the way physics works. But we can change the big numbers. So I want to write on here, you can change the big numbers. The big numbers. In other words, they're called the coefficients. Coefficients. So you can't change the little guys, but you can change the big ones. All right? Let's now do some examples once we get that last little bit of writing down there, if you're adding that to your little thing. So you can't change the little numbers, but we can change the big numbers that exist out in front. Some people wanted to write that last little bit, so I'm waiting there for a moment. Okay, so if you were away yesterday and you didn't watch the video, because I did put a video out there, if you were away yesterday and you didn't watch the video, then you're going to want to pay very close attention to what I'm doing here. For those of you who were here, okay, we're going to be writing down all those values for those elements underneath them, just like we did. Now, let's take a look at this reaction. And I want you to write this reaction down. And you can imagine that there's blanks here in front of these, where we're going to put the coefficients. And what we have to do is we have to manipulate these numbers so that all of the h's on the left is equal to the h's on the right. And all of the o's on the left is equal to the o's on the right. Now, when I look at this, I might look at the h's and I might say, well, how many h's do I have here on the left? How many h's are there? Yep, Tyson? No, there's actually two. So this is where what we did yesterday comes into play. Because I don't have a coefficient here yet. So I could say that h's, right, is equal to, remember, 1 times 2, right? Because, and this is for the people that were away yesterday, all right? So the 1 comes from here. When we don't have a number, we have a 1. The 2 comes from here. So that 1 comes from there. The 2 comes from there. And so how many h's do we have? 2. 2 h's. And I can do the same with the o's. O. 1 times 2. So how many o's? 2. Now I'm on the right side. I'm going to put a little line there to divide that up. For the h's on the left, 1 times 2. 2. And how many o's? How many o's on this one? 1 times, and notice here, there's no number, so that's a 1, okay? 1 times 1. Is this equation balanced? No, why not? The coefficient is the big number, okay? All right? The subscript is the little number. But in the end, we need the same types of atoms and the same number on both sides. So let's take a look at the h's. How many h's are on the left? How many h's are on the left? 2. How many h's are on the right? 2. How many o's are on the left? 2. How many o's are on the right? Is this balanced? No. Notice what we have. What we have here is, the reason it's not balanced is I have a 2-1 situation here. See that? See that there's a 1 O there, but there's 2 O's there? So I need to change one of the sides so that the O's are the same. So what am I going to have to do to make this become a 2? And the only thing I can change is the coefficient. Make it 2. So here's the way we can think about it. Now, people who like really nice, neat notes, are not going to like what I'm going to do here because I'm going to start crossing things out and changing some numbers. So what we need to do is we need to make this become 2. If this has to be a 2, I can't change the subscript, but I can change the first number. So what does this number have to be? It has to be a 2, which means I have to have a 2 there, right? Because the first number is that coefficient. That's why I put it first. But if I change the 2 here, what did I change here? Also this 2, right? Because it changes together. It's the coefficient. So how many h's do I now have on the right? I now have 4. So by changing that, I've thrown the h's out of balance. So now I'm going to go back and do the h. What do I need to do to fix this h? Where am I putting the 2? In the front. I need a coefficient of 2 because I need that to be 4. And the only way I can have something times 2 be equal to 4 is I need a 2. So in my system that I've built for you guys, the first number is the coefficient. I can change those numbers. The second number is the subscript. I can't change those numbers. They're built into the formula. I could have done this a little quicker. If I didn't need to rely on all of these numbers, this is the way I do it because I've done it for years. I look at this 2 and I look at this 1 and I know I'm in trouble right away. So what I do is I do the opposite. I take that 2 and I put it there as a coefficient. Now I know that I've got 2 O's. I can actually do this calculation down here, up here in my head. Now I can go in my head. 2 times 2 is 4, right? Now I can go back to the other side and I can say, I need 4 of these. I know there's a 2 there that I can't change, so the only thing I can fix is the 2 out front. All right? Let's do another one. It would be really nice if we could do this in our heads without writing down all those calculations. But if we can't, that's okay too. Again, there's blanks in here. We can imagine them as being blanks. Blank, blank, blank. For now, you could imagine as if they're all ones, because they really are. And in the end, we've got to put some numbers in those blanks in order to get the atoms to be the same on both sides. Again, because I have done this for years, I'm looking at this, and right away I'm looking at one of the elements that concerns me. I have a concern about one of the elements because I know it's not going to be easy to make the numbers the same. Which element up there am I looking at that concerns me? Yep, Jacqueline? The CL. The CL3, correct. Because I have a CL3 on the right, but what do I have on the left? A CL2. 2 and 3 don't line up unless I trade them around and I put their numbers as coefficients. What if I were to put a 3 here? If I put a 3 here, 3 times 2 is 6. 3 times 2 is 6. If I put a 2 here, 2 times 3 is 6. Then you can deal with your nitrogen. Okay? Now, in an ideal world, we don't have to write everything down underneath. But sometimes we need some help, and we do need to write it down underneath. I'm hoping that by the end of this process, you can do it without it. Let's go through the process without doing it, and then we'll write it down underneath to check. So the 3 and the 2 concerned me. So what did we do? We decided to switch it over and put the 3 there and the 2 there. Okay? Which then allowed us to think about 6 and 6. Let's look at the ends. How many n's do I have on this right-hand side? How many n's are there? There's 1, but times 2 is 2. I've got 2 n's on the right. How many n's do I have here? 2. 1 times 2. Is this balanced? We think it's balanced. I'm going to check just to make sure. So to check, I'm going to do exactly what I've done before. 1 times 2 is 2. Remember, the first number is the coefficient, the second number is the subscript. For the CL, 3 times 2 is, and if you're terrible at math and you don't know what 3 times 2 is, get a calculator to sit there. Don't tax your brain over 3 times 2. All right? 3 times 2, calculate it. N's, 2 times 1. Remember, if there's nothing there on the n, it's a subscript of 1. 2 times 1 is 2. CL's. 2 times 3 is 6. Is this balanced? Yes, it is. We've done the check. Okay? So ideally, we want to be able to balance it without having to write down all these things. Then we write them down to check. Then we know we've got it balanced. Okay? So you can see there, that situation presented a 2-3 situation. It was concerning us for a moment, but we know if we swap it, we can make that into a 6. Actually, I think if we were to go back to the first one that we did, and I'm actually just going to go back for a moment just to point it out. If I go back to this, look at here. 2 and 1. Switch them. It's like we did a moment ago. That gets you to put your 2 up there right away. And then you don't need to write it all down. All right, that's fun. Oh, let's bring that up. Oops, sorry. Did everyone get that written down to where they want it to be? Just want to make sure everybody has it so that we can go back and look at it. Okay, let's do another one. That's fun. Click. Oh, and I didn't really leave a lot of space in here. I apologize. Leave yourself some space for the coefficient. I didn't leave enough space when I typed that up. Which element do you think we should leave for the end to balance last? Which one should I balance last? What do you think, Pat? Yeah, that's exactly correct. I would say FE. Why do you think he said FE? Yep. Sorry? I don't think it's necessarily because of the existence of this 3 that I would say to do it last. I would say it's for a different reason. What do you think? What do you think? Pat, what do you think? Why'd you pick FE? Because it's first. That is not the reason. Right on! It doesn't have a number beside it. It's easy to change the number at the end, isn't it? It's not going to mess anything up. The O has a 2 with it. That's going to get messed up if I don't pay attention. It doesn't have a number beside it, so it's easy to do last. Correct. So let's deal with the O's first. Let's see if we can do this without writing down our little accounting. How many O's right now does it say here on the left? 2. How many are on the right? So what am I going to need to put as the coefficient in order for that to happen? 2. 2. Now FE is looking pretty easy, isn't it? How many FEs on the left? And how many on the right? So what am I putting as the coefficient? 3. 3. Now we check. If you're stuck still on getting the coefficients, you can still always write it out and scribble and change those coefficients to make it work out. Let's check. Notice I'm just leaving that as a 1, so it's staying blank. FE And some of you are probably going, do we really need to check? I can see it right there. It's obvious. The check is good. What would I do on a test? On a test, I'd likely make you check for one, show me for sure, and then I might just make you balance some, right? We don't necessarily, you can actually check in your mind pretty good, but I'm going to check officially on the slide here. So, the coefficient, 3 times 1 is 3, 2 times 2, first 2, second 2 is 4, and this is a 1, so FE is 1 times 3, right? 1 times 3 is 3, and O is 1 times 4, 1 times 4 is 4. 3 and 4, 3 and 4, we're in good shape. Okay? All right? All righty. How many examples do I have? This next one's a mean one, I think. Oh, that's so mean. And then, oh, that one there. Okay, now we're into 2 more examples, and then I'll give you the sheet, and I'll let you then work away on the sheet. This one's a little evil. Okay, it's a whole lot evil. It's a whole lot evil. Why is this evil? What is it that you're looking at as you start to analyze this that makes you go, wait a minute, this isn't very nice? What is evil about this? Cade? The brackets are there. We have to take into account it's a polyatomic ion, and it does have something to do with the brackets, but there's another reason. What do you think is going to be really hard to balance here? Which element's going to be really hard to balance? Hydrogen? Why might hydrogen be really hard to balance? There's 2 on one side. There's 2 on one side. So that's going to be pretty tricky. That's actually going to give me a hint on what I should maybe leave till the end. What should I leave to the end? Hydrogen. I should leave hydrogen to the end, because then in the end I can try to fix this one to make everything good. So let's leave hydrogen to the end. All right. Well, if we're going to leave hydrogen to the end, then I've got to deal with oxygen and aluminum, right? It doesn't matter which one we do first. Let's do aluminum. How many aluminums here? 1 times 1 is 1. How many aluminums here? 1 times 1 is 1. Good. Next, oxygens, I think, is the way to go. How many oxygens here? 1 times 1 is 1. How many oxygens here? 3 because of the brackets. That also makes it tricky, right? Remember, the 3's got to go in the brackets. So there's 3 oxygens here. What do I have to do here to take care of that? I need 3 of these so that I can say 3 times 1 is 3, and 3. Okay? Now we're dealing with the hydrogens. I think maybe it might be worth writing down the hydrogens here. How many hydrogens do we have here? H, 3 times 2 is 6, right? I'm going to count these hydrogens, and then I'm going to, oh, you know what? This is super evil. This is super evil. Why did I pick one that was so evil? How many H's do I have here? Yeah, 1 times 3 is 3. Holy cow. This is super evil. This is one that I would maybe give the grade 11s. Well, we're this far now. Let's keep going. I'm going to want to change this number. How many H's have I got here? 1 times 2 is 2. That's just mean. That is just so mean. Are they balanced? No. How many more H's do I need on that one side? 1. Is there a way for me to get 1 H? I can't just add an H. This is evil. I didn't want this one to be so evil. I'm gonna show you how I would do this with the older guys, because there's no real easy way out of this. If I want this to be 3, what do I have to have here as the, what's that? I need 1.5. Did you see that math there? Right, if you did 1.5 times 2, that gets you 3, doesn't it? So you know what we're doing here? We're doing a little bit of a cheat move. That turns this to 1.5. Okay? Now that means I'm going to write up here a 1.5. Yep. So, is that now balanced? It is, but it breaks the rules of how to officially balance chemical reactions. The official rule is you can't have any 0.5s, all right? So what you have to do is you have to double everything. But you know what? We're not going to worry about this in this course. If you can use a 0.5, use it, all right? We're going to put it out that way. If you can balance it with a 0.5, then that's great. We're going to consider that balanced. We're going to be done that one. I don't want to go any further on doubling everything. Are we okay with maybe using a 0.5 as that little move? It's a little bit of a cheat move. It's kind of fun. One more. And you'll notice for homework, there are textbook questions, but I'm going to want you to go straight to the assignment and work on the assignment when we get done. The textbook questions, you can save them for later, maybe in preparation for a test. Okay, let's do this last one. Blank, 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 blank. Also an evil one a little bit. Why is this one a little evil? Yep. That's okay. You're doing the whole procedure. You're doing it very nicely. What you're saying there isn't true, or isn't untrue. What you're saying there is true. But what you're doing is you're actually starting to balance it in your head. That's great. But that's not necessarily why it's evil. You've actually touched on why it's evil. You're correct. There's O's in 2 places again, right? Just like there were H's in 2 places. What should we do last here? The O's. When you've got it in 2 places, you need to deal with the O's. So that means I can start with the C's or the H's. I would start with the C's. How many C's on the left? 2. How many C's on the right? 1 times 1, because there's a little subscript 1. All right, that's for Justin who can't see it. Are you okay with that? So what do I have to have here? A 2. I have to have a 2. 2 and 2. H's. How many H's on the left? How many H's right there? So what do I need here? I need a big 2. 2 times 2. 2 times 2. Now the O's. Because I have O's in more than one spot, I'm going to add them up. I'm going to write them down as being an addition so we can see them. O's. 2 times 2 is 4. And O's here. 2. Oops. I'm going to write O's like I do. 2 times 1 is 2. So how many O's in total on that side? 6? So what am I going to need here? 3 O's. 3 times 2 is 6. Okay? Do the O's last when you get one like that. By the way, that's called a combustion reaction. We're going to learn about it tomorrow. It's when you take something and burn it in oxygen. So it's that oxygen that tells us it's combustion. Okay, I'm going to stop right there, and then I'm going to show you the assignment, and you guys can start working on it. And there may even be some time tomorrow at the end of class to work on it as well. So hopefully we can get it done in those couple of days. Let me just finish my video here, and then I will take your question. It clicks.